Today we're completing up the play ball activity, and today we're going into the inequalities with absolute values. And so when we talked about this earlier, when we first started this unit, is we had W minus 145 and 45 thousandths. The absolute value of that quantity is equal to 3.295, and that gave us our two endpoints. Gave us this point here, which was at 141.75, and this endpoint here, which is at 148.34. But what we need to take and consider is we're not looking for the balls that weigh exactly each of those two spots. We want to find all the balls that would fall between those two. So anything that'd be in between. And so when we want to write an absolute value inequality to represent that, we'll start off with the equation that we had. But instead of putting the equal sign, we're going to come back to that in just a second. So are we wanting remember this was our difference. This was our target. Are we wanting that difference to be more or less than 3.295? We want it to be less, but we could also be equal to it. And so we're wanting everything that's less than or equal to it. So we're wanting everything that would fall between those two things. And so it's really not even that number line. It really is along the absolute value bar, all of these weights. We want all of those numbers. And so if we look at it, if our ball weighed 147 grams, we would take 147 minus the 145.045, and we can subtract that and take the absolute value. And that would give us 1.955. Is this number, we want to see is that number less than or equal to 3.9295? And the answer is yes. So the answer to this problem is yes. So now we're going to take the same thing and you're going to plug in each of these items. And so you should have come up with this one would be no and yes and yes, because it's less than or equal to. So if we were to draw this on the number line, we'd have this point here, which is at 141.75, and we'd have this point here, which is at 148.34. But really what we have is everything that's in between those two. So the smallest number we have is 141.75. And we want everything that's greater than that, but also less than 148.34. So in other words, we want it to be sandwiched between those two things. This means that you have an and between this. When you're set up like this, that means it has to cover both things. So, but Raymond has the job, he has to dispose of all the balls that don't fit the qualities. And so he is looking for, instead of sorry, I just lost the number, 145.045. He's looking for the balls that weigh less than 3.295 away. And so what that means is we already know the two endpoints. We know this is at 141.75, and this is at 48.34. But this time, we're looking for all the ones, oops, I put the wrong symbol. All the ones that are greater than 3.295. So we want a difference of more. And so that means we want this side and we want this side. And so we want when x was less than 141.74 or 75, or because it has to be either side, it can't be both, when x is greater than 148.34. We're going to do this the same idea, but with Little League baseballs. And we're going to talk about the diameter. The diameter of the ball has to be 7.47 centimeters. And the diameter can have a difference of up to 1.27 centimeters. So let's look at our inequality symbol, our equation. And so remember, this is our target, and this is the difference. So our target was 7.47, and our difference was 1.27. So if we're trying to figure out what fits the criteria, we want it to be less than or equal to that. So we're going to focus in on the algebraic, because the graph that was provided has not got a good scale for graphing. And so we have x minus 7.47 is less than or equal to 1.27. And remember how we had the two different people, Bob and someone, can't think what her name was. And Bob changed all the signs inside the absolute value. And I said that if you use his method, it's going to make it easier going further. And so we are going to take and change all the signs inside the absolute value on the other one. So as a negative x and a positive 7.47 is less than or equal to 1 27/100. Now, the next thing, anytime it's a less than, you're going to write and. So we're going to take and solve each of these equations. So we're going to start with one side, just like you did with the absolute value equations. And when we add that side, we end up with x is less than or equal to 8 and 74/100. On the other side, we subtract the 7.47 from both sides. And we end up with negative x is less than or equal to negative 6.2. Now we need to divide both sides by -1. And when you divide by a negative, not only does it change the sign on the other side, but it also changes your inequality symbol. And so we now have x is greater than or equal to a positive 6.2. And we had and in the middle. And so when we have and, it means it needs to cover both. So it needs to be both greater than 6.2, but less than 8.7. And this is the one we set up with the variable in between. And so that is our solution. And when you look at it, it's what would be between those two intersection points if we were to graph it. So algebraically, we want to take in, so that goes with C. That's us doing up to C. Next, we want to see what would not fall within the new specifications, and we're going to write it as an inequality. And so let me add a page here. I lost my page that was added. So we have x minus 7.47 is, what we're throwing out is everything that's greater. And so we're going to do the same thing. This time, since it's greater, we're going to use the word or. We're going to use Bob's method, so we're going to just take and write down what's inside. And going to set it greater than 1.27. And so we're going to do the other one the same idea, but we're going to switch all the signs around inside. So negative x plus 7.47 is greater than 1.27. And you're going to solve. So moving everything around. Everything is going to stay pretty much the same. It's just our sign that changed. And that gives us x is greater than 8.74 or 7.47, subtracting it from both sides. Negative x is greater than negative 6.2. And now I need to divide both sides by negative 1. And so x is less than a positive 6.2 because of this negative here, we had to change this sign. So this time we're or. That means it's one location or the other. So we need to be less than 6.2 or greater than 8.74. So this right here is a chart that most people have learned to use and solve inequalities with. But if you use, I think it was Bob's method, then all you have to remember is less than is and, which covers what is covered by both. So you can use the word and it's what's covered, both cover. Greater than is or, and it's what is covered is everything that is covered. And so when we look at this, we're going to go ahead and solve and try to figure out what each of these things are. So this first one, we're going to go ahead and set it up. X plus 3 is less than 4. And since it's less than, we're going to use the word and. X plus 3, negative x minus 3 is less than 4. Subtract the 3, you get x is less than 1. Add the 3, negative x is less than 7. So when I divide by negative 1, it causes my inequality symbol to switch. And I get negative 7 over here. So I am, x is greater than negative 7 and less than 1. Since there is no bar, then it's an open circle. And so at negative 7, I'm going to put an open circle. And at 1, I'm going to put an open circle. And we're going to shade because greater than negative 7 is going to shade this way. Less than 1 is going to shade that way. This one, our absolute value is on the wrong side. So we must flip it, because we need the absolute value on the left. And so 2x minus 4, the absolute value of that is greater than or equal to 6. And since it's greater, that means we are going to use the word use the word or. And so we write up our two equations. It's greater than or equal to 6, or opposite signs, negative 2x plus 4 is greater than or equal to 6. And so we add the 4, we have 10, divide by 2, x is greater than or equal to 5. We subtract the 4, we get 2, negative 2x is greater than or equal to 2. Divide both sides by negative 2. When we do that, it flips the inequality symbol. This time we are looking for when x is less than or equal to negative 1, or when x is greater than or equal to 5. So at negative 1, I'm going to put a closed circle because that bar, and less than means I need to shade to the left, so it's everything to the left. And remember, or means everything covered. And so at 5 is greater than 5, so that means I need to shade to the right. So that's our solution. This one's very similar, except for we now have things on the outside. But if we keep in mind what Bob was talking about, where we take and go, okay, everything on the inside stays the same. And it's less than, so that means it's an and. Change our signs on the inside, so plus 5x minus 8. And then the plus 2 stays the same. And the inequality stays the same. And the 25 stays the same. Those two we change. And so combine like terms, those two become 10. Negative 5x plus 10 is less than 25. Subtract the 10 from both sides. Negative 5x is less than 15. Divide by a negative 5. So since we're dividing by a negative, causes our inequality to switch directions. And so x is greater than negative 3. So at negative 3, I put an open circle because it doesn't have a bar underneath it. And let's go over and solve the other one. We have 5x. These two combine to become a negative 6. We add the 6. And we have 5x is less than 31. Divide both sides by 5. X is less than 31/5, which is equal to 6.2. So that means we're right over here. And we have an open circle at that 31/5. And so and means I need to have what's covered by both. So I need to look ahead. We want what's greater than negative 3 and what's less than 31/5. So that would be shading between. So when I rewrite the equation for the answer, negative 3 is less than x, which is less than 31/5. We have two more. These two have a little bit of a trick to it, so kind of watch for the trick. So when is the absolute, actually let's cover that part at the end, and we'll talk about it a little bit at the end. So we have the absolute value already on one side, on the left-hand side. So you have x plus 5 is greater than negative 1. It's greater, so that means it's or. Change all my signs. And we solve it. Minus 5 is negative 6. And we add the 5, negative x is greater than positive 4. Divide both sides by negative 1, which causes that to change. And so, or means I want everything that's covered. So at negative 6 and at negative 4. So at negative 4, I shade back this way. At negative 6, I shade this way. So that means I covered everything. So it's all real numbers. So I want you to think about it. If we look at the original problem, let's think about it. The trick is, when is absolute value greater than a negative? Always. So that automatically takes you down to the all real numbers. Let's look at this next one. X plus 5 is less than negative 1. It's less than, so that means it's and. Negative x minus 5 is less than negative 1. So we're going to solve each one of these. I know it's the same numbers we were just working with, so if you just want to kind of shortcut through and get to that point, just be careful in this other one that you're not changing up what we're doing. And you remember that we have our inequality symbols looking different. So when we flip it, it's going to become greater. So we want everything that's greater than negative 4, but less than negative 6. And means it has to be covered by both. So nothing is covered by both. So it's no solution.